Hello everyone, today we're going to look at the polar form of a complex number. Before we can get into the polar form, we're going to talk a little bit about graphing a plus bj. So what we're going to do is we're going to transform rectangular form into a coordinate system. So a plus bj is going to become the point a comma b. So if I want to graph, say, 3 plus 2j, I would go 3 on the x-axis, which we call the real axis. That looks terrible. I just rewrite that. The real axis. And then the y-axis is called the imaginary axis. So we'll go 3 on the reals and up 2 on the imaginary. I'm just going to make a circle right there for A. For B, I'm going to do it in blue. -1 in the reals and 3 in the imaginary. So I'm going to go to the left 1 and up 3. And then for -4, that is a real number, so there's nothing on the imaginary axis, so there's no up or down, and it's just 4 to the left. Oops, that's a little close enough. And then lastly, -3j, there's nothing on the real part, so I'm not going left or right, and I'm only going, in this case, down 3. So that's how we would graph an imaginary number. And we want to keep that in mind when we talk about changing it into the polar coordinate system. So next we're going to look at the absolute value. So remember, the absolute value of a number is the distance from 0. Before, we'd only talked about this in the one-dimensional case, but now we've got 2 dimensions, the real and the imaginary. So our 0 is the origin, or 0, 0. The distance is just the Pythagorean theorem, right? If I have a point, say over here, we're going to do the Pythagorean theorem to find that distance. So here would be my distance in A, and here would be my distance with my B, because again, this is my real number, or my real part. B is my imaginary part, so that's the up and down, that's the y-axis. So we've got the square root of a squared plus b squared. We're going to call that r, and we're going to see that that's something that's very much used in the polar form. We're also going to look at the reference angle. So really, if I have a point on here, and again, I'll just put a generic point over here somewhere. So if I'm looking at that point, then what I'm going to do is I'm going to turn that into a vector, and I'm going to connect it to the origin. And then remember, with vectors from Tech 1, we had the r, the distance, or the length of the r, and then also the angle. So just like with the vectors, we have this condition to find r, and we have this equation to find the reference angle. So remember, if I'm over here, say, in quadrant 3, I want the angle, but I'll be able to find the reference angle, which is down here. So the reference angle is this tan inverse of absolute value of b over a. Okay, so if I know my a plus bj, I can find my r and theta. And this r and theta are used in what's called polar form. So going backwards, and again, this is all from what we learned with the vectors, and it's also from SOHCAHTOA. So A would be r cosine theta, and B would be r sine theta. And again, that's from SOHCAHTOA. Right, the tangent is the TOA part. And then so, again, if I've got something, let's say it's in quadrant 1, the sine of theta is the opposite, which would be b, over the hypotenuse, which is r. So bring the r over, and b equals r sine theta. The same thing with cosine, right? Cosine of theta is adjacent, which is the A, over the hypotenuse. So we bring the r over, and that gives us A equals r cosine theta. So again, it's the same thing from the vectors, it's the same thing from SOHCAHTOA, which we learned in Tech 1. So this really isn't anything new, except for the fact that we're now converting it in from polar form instead of those, say, x and y components. Okay, but it's the same stuff. So what we're going to do is we're going to kind of put that together. So A plus BJ is r cosine theta plus rj sine theta, based on what we just talked about. And we can pull out the r, or factor out the r. And this is a shorthand way of writing r times cosine theta plus j sine theta. So this is r, you can say angle theta. So it gives me the r, it gives me that length, and it gives me theta. All three of these that have the r and the theta are called polar form. So if you see cosine and theta and cosine and sine, and you see a theta, you see an angle, that is polar form. So what we're going to do is we're going to convert from rectangular form to polar form. And unless it's an integer, we're going to round each part to the nearest hundredth. So we have in polar form 10 angles 60 degrees. So that just means it's 10 cosine of 60 degrees plus 10j sine of 60 degrees. And then I'm going to plug those into my calculator. 10 cosine of 60 degrees is 5. Cosine of 60 is exactly a half. And then 10 sine of 60 degrees is 8.66. Don't forget the j, right? It has to be in rectangular form, so a plus bj. If I have 2 with an angle of 200 degrees, again, that just translates into 2 cosine of 200 degrees plus 2j sine of 200 degrees. I plug both of those into my calculator, and I get negative 1.88 minus 0.68j. Before I continue, you always want to check, does my answer make sense? So I'm going to go back to A for a second and look at my angle. My angle, 60 degrees, is in quadrant 1, and my A and B, which would correspond to X and Y if I was graphing it, are both positive, so that makes sense. In part B, 200 degrees, that's quadrant 3, and both of my A and B, and therefore my X and Y, are negative, and that makes sense for a quadrant 3 angle. How about 30 with an angle of 315 degrees? So that means 30 cosine of 315 degrees plus 30j sine of 315 degrees. Plug them both into my calculator. I get 21.21 minus 21.21j. 315 degrees is quadrant 4. So X or A is positive and B or Y is negative. And that will give us a quadrant 4 complex number. And then 12 with an angle of 115 degrees. So and that just translates to 12 cosine of 115 degrees plus 12j sine of 115 degrees. 115 degrees is quadrant 2. So when I get my answer, I know that my X or my A should be negative, my real part should be negative, my imaginary part should be positive. And I get just that, negative 5.07 plus 10.60j. Let's convert from rectangular form to polar. And again, unless it's an integer, we'll round each part to the nearest hundredth. So 2 plus 3j. So I know it's in quadrant 1. So I know at the end of things, my angle should be between 0 and 90. So I'm going to keep that in the back of my head. R is going to be a square root of a squared plus b squared. So 2 squared is 4, 3 squared is 9. So that would give me the square root of 13. Rounded to the nearest hundredth would be 3.61. Right, remember that your r is the hypotenuse of the triangle, so your r has to be bigger than both a and b in absolute value and less than the sum of the absolute values. So I know it's got to be at least 3, and it can't be more than 5. So 3.61 makes sense. The reference angle would be tan inverse of, I don't need the absolute value because my a and b are already positive. So I want tan inverse of 3/2. That gives me 56.31 degrees. Again, my angle is in quadrant 1, so my angle is my reference angle, which again is 56.31 degrees. My answer in polar form is one of those 3 versions that I wrote. This is usually the quickest, well, it is the quickest way to write it. So you'll usually see me writing my answer using that angle notation. So 3.61 with an angle of 56.31 degrees. How about -4 plus 5j? So r will be the square root of, and -4 squared is 16, 5 squared is 25. Remember, a negative number squared is still positive, so there's no negative numbers in here. They're both positive. And rounding to the nearest hundredth, that'll give me 6.40. Again, bigger than a and b, smaller than the sum, again, in absolute value. Theta reference is tan inverse of positive 5/4. So these negative signs in here are only there to tell you direction. So it's only there to tell you what quadrant you're in. So I don't actually need them in the formulas for r and theta. So that'll give me 51.34 degrees. My angle is not 51.34 degrees because I'm not in quadrant 1. Right, with a negative x and a positive y, I am in quadrant 2. And if we remember the formulas for that, quadrant 2, the angle is 180 degrees minus the reference angle. So 180 minus 51.34 degrees gives me 128.66 degrees. Again, my final answer, I can't just leave r as this and theta as this. I need to put it in polar form. So again, this is the fastest way to do that. So how about 5 minus 12j? So r is going to be the square root of 25 plus 144. So again, 5 squared plus -12 squared. That's going to give me an exactly 13. The reference angle will be tan inverse of, again, positive 12/5, which will be 67.38 degrees. My angle, I need to look at what quadrant is this in. So my real is positive, my imaginary is negative, so that is going to be here in quadrant 4. The formula for quadrant 4 angles is 360 degrees minus the reference angle. So my angle is 292.62 degrees. I put it together, and here's my final answer in polar form. About -1 minus j. R equals the square root of 1 plus 1. A is -1, B is -1. When I square them both, I get +1. And that is the square root of 2, which is 1.41, rounded to the nearest hundredth. Theta reference is tan inverse of 1/1, which is just 1. Tan inverse of 1 is 45 degrees. Both my A and B are negative, so that is quadrant 3. And that formula is 180 degrees plus the reference angle, which will give me 225 degrees. So my answer would be 1.41 with an angle of 225 degrees. And now we have the number 40. So notice that A is 40, B is 0, right? I can always write this as 40 plus 0j. So R is 40 squared, which is 1600 plus 0, which is 40. Theta reference is tan inverse of 0/40, which is just 0. And that gives me 0 degrees. my angle is my reference angle, and that's 0 degrees. I can think of it in two different ways, right? 40, oops, that's not the right. 40 is over here. It's a real number. There's nothing in the imaginary part, so I'm right there. So I am between quadrants 1 and 4. So I can think of this really three different ways. One, it is on the positive x-axis, and that is 0 degrees. I could think of it as being in quadrant 1, in which case the reference angle is the angle, which is 0 degrees. Or I could think of it as being in quadrant 4, which would be 360 degrees minus 0, which is 360, but 360 degrees is 0 degrees. So it's three different ways I can think of it. It is the positive x-axis, or it's in quadrant 1, or it's in quadrant 4 with a reference angle of 0. So in either case, we get that it's 0 degrees. So a real number, if it's positive, will be at 0 degrees. If I have a real number that's negative, my angle would be 180 degrees. Right, so if I had negative 5, that would have a distance of 5 and an angle of 180 degrees. So remember, r is always a positive number. Okay, so that's the distance, and if it was negative 5, that distance would be 5. The angle tells me that it's a negative number. How about negative 7j? So here my a is 0, and r is the square root of 0 plus 49. Square root of 49 is 7. The reference angle would be tan inverse of 7 over 0, which is undefined, and you can't really plug that into your calculator. But if we remember that tangent is the same as slope, we're looking for what angle has an undefined slope. Undefined slope is a vertical line, so that is either 90 degrees or it's 270 degrees. So it's going to be one of those two, 90 or 270, and that depends on if my j value is positive or negative. So if my j value is positive, or my b value rather, the imaginary part's positive, then I'm at 90 degrees. If my imaginary part's negative, I'm at 270. So I can think of the reference angle as being 90. And then my angle would be, again, I have those same three ways to think about it. I'm on the negative y-axis because it's negative 7j, so that's 270 degrees. Or I can use the reference angle being 90, and I can think of it as being in quadrant 3, which in case it'd be 180 plus the reference angle. So 180 plus 90 is 270. Or I could think of it as being in quadrant 4, where it would be 360 minus 90, which is also 270. So again, there's a couple ways I can think of it, but it all leads me to 270 degrees. So I have a distance or a length of 7 and an angle of 270 degrees. Okay. So again, a real number will be 0 or 180 degrees. An imaginary number will be 90 or 270 degrees. Okay. So make sure you read through the book, and let me know if you have any questions on polar form. Thanks.